Hello, everyone, and welcome to Notes on Slope Intercept Form. Let's dive right into it. So, I'm going to be using a lot of color to help you decipher different things. So, the slope intercept form is y equals mx plus b. So, m is slope, or we also call it the rate of change. B is the y-intercept. It's also known as the initial value. So notice I put the slope in red. And it's one of the biggest misconceptions that people have is if I ask what's the slope of an equation, they'll say, oh, slope is 2x. Well, the x is not a part of the slope because notice the x is not red, only the m. So whatever number is in the m spot is actually the slope. The x is not the slope. So let's look at some examples, just taking slope and y-intercept and putting it into the formula. So we know we're going to have a y equals and we're going to have an x. So let's look at here. Our slope or our m is 2. And our b here is -1. So I'm not going to put plus b. I'm just going to put negative or -1. So instead of writing plus, that's why the plus is in blue, because it could change. It could be plus or minus, okay? And I could put that up to plus or minus b. All right, so here we go. The next one, we got y equals, and I go ahead and put my x. Well, my slope is -3/2. And my b, in this case, is a +4. I'll do one more just in case. I got y equals, and I'll go ahead and put my x. My slope is -3, and my y-intercept is +2, so +2. Let's go look at some graphs here. So the first thing I like to do when I do graphs, so we know the equation is y equals mx, and I'm going to say plus or minus b. Okay, so the first thing I like to do is I like to establish the y-intercept. So the y-intercept is we have the y-axis, and it's where this line here crosses the y-axis. So in this case, the y-intercept is right here. It crosses the y-axis there. And that number is -1, -2, -3, -4. So my b is actually -4. So my slope, remember we talked about finding slope from a graph, which is rise over run. So rise being positive or negative, run being, left to right, positive, negative. In this case, we got to go up. So up is 1, 2, 3. So up is positive. So we went up 3. And we went to the right 1. Right is +1. So we have 3 over 1, which is equal to just 3. So my slope is 3. So my equation is, I'm going to put y equals, and I can put my x, 3 minus 4. We have another graph here. And again, we like to identify our y-intercept. So our y-intercept is where this line here crosses the y-axis, which is here. So we can say that's 1, 2, 3, 4, 5, 6, 7. So my y-intercept is 7. So in this case, we're going to go from here to here. So we're going to go down 1, 2, 3, 4, 5, 6. We went down 6. And we're going to the right 1, 2, 3, 4. So we went right, which is +4. Now I can simplify this by simply dividing this by 2. So that gives me -3/2. So my slope is -3/2. So let's go ahead and put that in equation form here. We have y equals, and my x, we got -3/2 plus 7. So now we're going to continue on, and we're going to do something a little bit more real world like. So we're going to talk about rate of change, which is just a slope. And we're going to talk about writing equations using different forms, okay? So I'm going to skip this one right here for right now, and I'm going to come back to it. Well, I'm not going to skip it. I'm just going to use this space to do it a different way. So let's go here. So it's the same exact table, and we're talking about rate of change, which is our slope, initial value, which we identified as our y-intercept, and we're going to write our equation. Now, of course, when you get these examples, we often give you easy tables. And I'm going to show you how to do it two different ways, algebraically and just simply with the easy table. So the first thing we're going to do is let's identify the rate of change. So rate of change or slope is the change in y over the change in x. And don't get all worked up on what that looks like. Let's just see how it works. So if I look at y, I'm going to start with the y because that's the numerator. How do we get from 10 to 6? Well, simply I subtracted 4. If I look at it again, how to go from 6 to 2? Well, I subtracted 4 again. And if I go 2 to negative 2, I still subtracted 4. So what I notice is it's a constant rate of change, which means that it's negative 4, which means that it's linear, which is negative 4. Now we got to find the change in what? X. Let's see if this is constant, okay? So we go from 2 to 4, which is plus 2. We go from 4 to 6, which is plus 2. And we go from 6 to 8, which is plus 2. So my rate of change, my x rate of change is 2. So negative 4 divided by 2 is simply negative 2. So my rate of change is negative 2, or my slope is negative 2. Now my initial value. The initial value is the value of y when x is 0. Well, in this case, we don't have an x equals 0. So, but this table is simple enough that we can work backwards, okay? So we know if we go backwards, we know if we're adding 2 here, the work backwards is subtract 2. So 2 minus 2, that equals 0. So we found x equals 0. And we can do the same thing on this side. The opposite of negative 4 is plus 4. So 10 plus 4 is 14. So we know our initial value, because x is 0 here, is 14. So our equation we have is y equals, and we can put our x, negative 2 plus 14. Now, we did it that way, but a lot of times you're going to have tables where the numbers are going to be large, they skip around. It's not going to be just this cut and dry. So another way of doing this, we're going to go here, is we're going to do algebraically. So we understand we have a y and we have an x. And so we got 1 and 2. So what you got is here is you look at this is y2, this is x2, this is y1, this is x1, because x, y, 1, 2, that's our points. So when we have that information, we can actually use the slope formula, which, remember, m equals y2 minus y1 over x2 minus x1. So y2 is 6 minus 10 over 4 minus 2. 6 minus 10 is negative 4. 4 minus 2 is positive 2, which gives us negative 4 divided by 2, negative 2. So we have the same slope is negative 2. But the issue is we don't know our y-intercept. And I'm showing you this way because just in case our numbers are all over the place or it's not easy to count backwards, here's a way to do this algebraically, okay? So we have y equals negative 2x, and we have plus b. So what we note here is we have points here, x and y. You know, I'll go down here, x and y. It doesn't really matter which point we use, but we have different points. So I'm just going to use the first point where I have a 2 as my x, 10 is my y. So remember, x and y. So if I have an x and y, I can actually substitute those values into the linear equation to find my b value. So if the table's ever too difficult to work back, remember, you find the slope, then you can substitute your x and y in to find the b. So in this case, y equals 10. You got 2 times x is 2. I'm sorry, negative 2 times 2 plus your b. So negative 2 times 2 is negative 4 plus your b. If you add 4 to both sides, you get b equals 14. So we find that we get the same b value if we solve it algebraically as 14. All right, let's go on to the next example. It says the admission fee for a local carnival is $8. Each ride, not like these, what I like to call change words. Each is one of them. And another one I can think of is per. And we'll discuss them as we see them in class. But when you see change words, that lets you know that's kind of your rate of change. Okay? So each ride costs $1.50. And then we can say that a local carnival, the admission fee, which means you're going to pay the same rate every time, is $8. So the rate of change, remember I said those each words is $1.50. So yes, I didn't write the zero because it's not necessary. So as you get in more advanced math, they just don't write the zeros. Or you'll even see your calculator. If you type 1.50 in the calculator, it's just going to change it to 1.5. The initial value is we pay an $8 admission fee. So my equation is y equals 1.5x plus 8. Here we have a graph, and then we're going to start with, I told you when you do graph, we always start with our initial value. That's where the line crosses. Remember, that's where this line crosses the y-axis here. Well, in this case, it crosses right here at 1. So my initial value is 1. My rate of change is just my slope. So what are we doing? We're going up. Well, we're actually going to go to this point here. We're going to go up 1, 2, 3. So we went up 3 and to the right 1. Now remember, if it's up, it's positive. Down, negative. So we went up 3 and to the right, positive 1. Excuse me. So 3 divided by 1 is just simply 3. So my rate of change is 3. So my equation is y equals 3x plus 1. Here's another graph, and probably our final example for today. Same concept. You want to find your y-intercept first, which is here. So my initial value is 3. Then we want to go from here, and we're going to see where this line hits the point, and it hits it right here. So we're going to go down 1, 2. So remember, down is negative. We went down 2, and to the right 1. So negative 2 divided by 1 is just negative 2. So my rate of change or slope is negative 2. So my equation is y equals negative 2x plus 3. I want to give you guys some bonus coverage here on this one. So I'm going to go here, and I want to give y'all, let me erase this up here, and I want to give y'all some bonus coverage on this video. So hopefully if you watch to the end, you'll get some bonus coverage. And we're going to talk about functions. F of h equals x squared minus 3x plus 5. And we discussed this in class, and we have h of x equals negative 2x minus 5 on both sides. So we have two different questions. One says find h of negative 3. And the other one says if h of x equals negative 25, find x, excuse me. So in this case, let's look at this. In this particular case, we have find h of 3. Notice that 3 is inside the parentheses. So if it's inside the parentheses, we're going to replace x, or every x. So we're going to replace x's. Now, on this particular side of this thing, it says, if I look at it, there's an x in the parentheses, so it says h of x equals 25. So it says equals 25. So if you see it like this, you're going to replace h of x. And sometimes be f of x, g of x, it doesn't really matter. Whatever it is, you're going to replace it. F of x, h of x, it doesn't really matter. We're going to replace it, okay? So let's set it up, okay? So on this side, we have, going to go squared, but instead of writing x now, we're going to put negative 3. And we have minus 3 times negative 3, and it's plus 5. So let's go ahead and work this out. Negative 3 squared is just positive 9. Negative 3 times negative 3 is plus 9, and we have a plus 5. 9 plus 9 is 18 plus 5. 18 plus 5 is 23. So we know that h of negative 3 equals 23. On this one, it's slightly different. So we're replacing h of x. So now here's our equation. We're going to put negative 25 equals negative 2x minus 5. So we replace h of x. So now we're going to solve for x. So we're adding 5 to both sides. What that gives us is negative 25 plus 5 is negative 20 equals negative 2x. Then we're going to divide by negative 2. And we have the x is equal to negative 20 divided by negative 2 is positive 10. So we know that h of, watch this, 10. So h of 10 equals negative 25 because we found what x was. Thank you for watching. Until next time.